Assalamu alaikum viewers, myself Hamdi Malik and welcome to the Knowledge World. Today I am here with a very important topic related to CSS, and that is about origin of the universe. There is a very famous quotation of Stephen Hawking, and it is: the problem of the origin of the universe is a bit like the old question: which came first, the chicken or the egg? In other words, what agency created the universe? And what created that agency? Or perhaps the universe or the agency that created it existed forever and didn't need to be created. This is a very famous quotation of Stephen Hawking. The question here is that how universe began and how it expanded. Big Bang theory plays a vital role in it. Big Bang theory is the leading explanation about how the universe began. At its simplest, it talks about the universe as we know it starting with a small singularity, then inflating over the next 13.7 billion years to the cosmos that we know today. Because current instruments don't allow astronomers to peer back at the universe's birth, much of what we understand about the Big Bang theory comes from mathematical theory and models. Big Bang theory. Most astronomers believe the universe began in a Big Bang about 13.7 billion years ago. At that time, the entire universe was inside a bubble that was thousands of times smaller than a pinhead, and it was named as singularity. It was hotter and denser than anything we can imagine. Big Bang theory is actually a theory about the beginning of the universe. So after it suddenly exploded. The universe that we know was born. Time, space, and matter all began with the Big Bang. In a fraction of a second, the universe grew from smaller than a single atom to bigger than a galaxy, and it kept on growing at a fantastic rate. It is still expanding today. As the universe expanded and cooled, energy changed into particles of matter and antimatter. These two opposite types of particles largely destroyed each other, but some matter survived. More stable particles called protons and neutrons started to form when the universe was 1 second old. Over the next 3 minutes, the temperature dropped below 1 billion degrees Celsius. It was now cool enough for the protons and neutrons to come together, forming hydrogen and helium nuclei. After 300,000 years, the universe had cooled to about 3000 degrees. Atomic nuclei could finally capture electrons to form atoms. The universe was filled with clouds of hydrogen and helium gas. These clouds of dust and gases formed all celestial bodies afterwards. Evidence for the Big Bang. By analyzing the spectrum of light from a star or galaxy, astronomers can tell how fast it is moving and whether it is moving towards Earth or away from the Earth. If an object is moving away from Earth, its light shifts to longer, redder wavelengths, an effect known as redshift. If an object is moving towards Earth, its light shifts to shorter blue wavelengths, an effect known as blue shift. Redshift supports the Big Bang theory. The light from distant galaxies is redshifted. This tells us that galaxies are moving away from us, and the further away the galaxy, the greater the redshift. This tells us that the more distant the galaxy, the faster it is moving. This means that distant galaxies are moving away from us, and more the galaxy is moving away from us, the more it is redshifted and the more faster it is moving. So this is the first evidence for the Big Bang. A second piece of evidence that supports the Big Bang theory is cosmic background microwave radiation. Arno Penzias and Wilson detected a cosmic microwave background radiation while studying radio signals. These radiations are received from all parts of the universe and is thought to be the heat left over from the original expansion or Big Bang. Some of the other theories argue that the Big Bang theory is based on a false premise. Some instead prefer to build theories on a static universe, which is what was originally predicted by Einstein's theory of general relativity. The ultimate fate of the universe. Once the notion that the universe started with a rapid expansion, nicknamed the Big Bang, became accepted by the majority of scientists, the ultimate fate of the universe became a valid cosmological question, one depending upon the physical properties of mass or energy in the universe, its average density, and the rate of expansion. There is a growing consensus among cosmologists that the universe is flat and will continue to expand forever. The ultimate fate of the universe is dependent on the shape of the universe and what role dark energy will play as the universe ages. Astronomers recognize four models of possible futures for the universe. Those four models for the future of the universe are: number 1, closed model or contracting universe theory. Number 2, flat model or steady state theory. Number 3, cyclic model or cyclic universe theory. And the last one and the fourth one is open model, which is also known as expanding universe theory. Here is also the role of Nicolaus Copernicus. Nicolaus Copernicus proposed a heliocentric, sun-centered model for the solar system, in which the sun is stationary at the center and Earth and other planets orbit around it. Before Copernican theory was accepted, astronomers believed that Earth was stationary at the center of the solar system, and the sun and planets revolved around it. Italian physicist and astronomer Galileo attempted to publicize Copernican theory in the early 1600s and was convicted as a result. Copernican theory was not widely accepted until the late 17th century. So this was all about origin of the universe. First I shared the quotation of Stephen Hawking, then I described the Big Bang theory, which is about the origin of the universe. Then I shared the evidences for the Big Bang, and at last and finally I shared the ultimate fate of the universe and the four models which astronomers recognize for the future of the universe.